So today we're going to talk about a very important skill, and I really suggest you watch this video multiple times and kind of understand where we're getting to with this, because this is going to be crucial in understanding the foundations of algebra, which 8th grade is, and going into algebra going forward. So what we're going to do today is we're going to be able to read questions and write formulas that are based off of the question. So number one, Larry's job earns $25,000. Gerald's job earns $40,000. Larry earns a $1,000 increase each year, and Gerald earns a $500 increase each year. What equation can be used to find X, the number of years it will take for Larry and Gerald to earn the same salary? So what this increase each year is telling us is that, so for instance, Larry's job starts at $25,000, but the next year it'll go up to $26,000. The next year it'll go up to $27,000, and the next year it'll go up to $28,000. Gerald's job starts at $40,000 and goes up to $40,500, and then $41,000, and then $41,500, and then $42,000. So they're both going up, and even though Gerald's is starting at a lot higher, eventually Larry's going to catch him because Larry's increase is a lot more than Gerald's increase. So think of it like this. I start with $10 and you start with $1, but I only get an increase of $1 each year, and you get an increase of $2 each year. So I start at 10, you start at 1. I go to 11, then you're at 3. I go to 12, then you're at 5. I go to 13, then you're at 7. I go to 14, then you're at 9. I go to 15, you're at 11. I go to 16, and you're at 13. I go to 17, you're at 15. I go to 18, you're at 17. I go to 19, and you're also at 19. So eventually, even though you started a lot lower, we'd end up making the same amount. It'll take some time, but eventually it'll get there. So what this question is asking is, even though Gerald starts at a higher base salary, eventually Larry's salary is going to be equal to his because it's increasing more each year. So here's what we're going to have to do. Two important things that we're going to need to write down, and I'm going to put a star so you can write this down. We're going to make sure the same person's numbers are on the same side. And secondly, the multiplication word is squished with the X. And lastly, we're going to look at some multiplication words. Per, times, each, every. So those are some multiplication words that will identify which one of these is being multiplied. So first we're going to start with Larry. We see that Larry's numbers are $25,000 and $1,000. So those two numbers need to be on the same side. And Gerald's is $40,000 and $500. So those need to be on the same side. So we're going to look for the multiplication word. And the multiplication word in this problem is going to be each. And Gerald earns a $500 increase each year. So we know that this 500 is going to be the multiplication word because it's with the each. We know that 1,000 is going to be the multiplication one because it's with the each. So the multiplication one is going to be squished with the X. So I'm going to start with Larry's side. We have 25,000 plus 1,000 X. And the reason this 1000x are squished together, say for instance, say we're 2 years into the future. Well, by now, his salary would have increased from 26,000 to 27,000. So it would have gone up 2. On the other side, we have 40,000 plus 500x. So what you need to know so far is that the multiplication is going to be the one that's squished together with the x. And there's several words we can use to find out these multiplication words. Secondly, we need to make sure the same person's numbers are on the same side. So Larry's numbers are $25,000 and $1,000. So they're both on the same side. Gerald's numbers are 40,000 and 500, and those are both on the same side. So this is the formula we would use to find how many years it would take for them to have the same salary. Now, the extra thing I want you to do, and I'm not going to do it for you, but I want you to solve and find out how many years it will take. So the way you're going to do this is you're going to hit F2. You're going to go to solve. You're going to enter the equation. You're going to enter comma x parentheses, and then you're going to click enter, and it'll tell you how many years it will take for those two to make the same amount in a year. So now we're going to go to number 2. Doug has 20 water bottles and gives X away every day. Judy has 30 water bottles and gives away 3 times as much as Doug. Which equation can be used to find X, the amount of days it takes until they have the same amount of bottles? So first, I'm going to find Doug's numbers, and this might help if I use different colors. So Doug has 20 water bottles, so I know that 20 belongs to Doug. And he gives away X amount every day. So I don't know what X is, but I know that's how much he gives away. I'm going to use a different color for Judy. So Judy has 30 water bottles and gives away 3 times as much as Doug. So those are her numbers. So both of those need to be on the same sides. This color needs to be with this color, and this color needs to be with this color. It says which equation can be used to find out the amount of days it takes for them until they have the same amount. So the same amount, just like here, is going to be telling us that we have an equal sign. So in the middle. So now we're going to take a look at some of the other parts of the problem. Let's see if anything's going to be multiplied together. So we have a couple different words. We have every, which we said is a multiplying word, which means it's going to be squished with the X. So good. And right here we have 3 times. So this says she gives away 3 times as much as Doug. So we know that this is going to be multiplied because it has that multiplication word. And we know that that 3 is going to be squished with the X. So we're going to rewrite our problem. We're going to keep Doug's over here and Judy's over here. So Doug is going to start with 20 water bottles. And now we're going to look at this word gives. So if Doug is giving water bottle and Judy is giving away water bottles, should their water bottles be going up or down? If I start with $10 and I give away 3, I'll have $7. Now, what formula am I going to use to figure that out? Am I adding? Am I subtracting? Am I multiplying? Am I dividing? So what I'm going to be doing if I'm giving something away is I'm going to be doing a subtraction problem. So how much is he subtracting every day? Well, he's subtracting X amount. We don't know what that is, but we know it's a certain amount. We know that's going to be equal to Judy, who has 30 bottles and is giving away 3 times as much as Doug. Well, what's 3 times as much as x if we don't know what x is? Well, 3 times x would be 3x. So here's our equation. Doug will start with 20 and give away an unknown amount of bottles of water. Judy will start with 30 and give away 3 times that much each day. So what we're looking for is x, and x will tell us how many days it'll take until they have the same amount. So once again, use the same steps right here. F2, solve, enter the equation, and click enter, and find out what this is as well. Another way we can do this is we can draw this out. And we're going to draw this out using a little chart. So we're going to say Doug starts with 20. Let's say let's say he gives away 1 bottle. You have 19, and then 18, and then 17, and then 16, 15, 14, 13, 12, 11, 10, 9, 8, and so on. So now we're going to look at Judy. In this case, let's say Doug clearly gave away 1 bottle a day, and 3 times that amount would be 3 bottles a day. So 27, 24, 21, 18, 15. So even though they're not perfectly lined up, because I'm drawing this here, we would see that they would have the same amount of water left after 1 day, 2 days, 3 days, 4 days, 5 days, after 1 day, 2 days, 3 days, 4 days, 5 days. So lastly, I need you to do number 3. So you're going to be interpreting this question and trying to figure out which one it is. So remember, the x and the x is going to be next to something that you're multiplying. All right. So the price of a ball is x dollars. Which situation can be represented by this inequality? 10x is less than 7x plus 12. So we're going to look at the rest of the problems, and what we're going to do is you're going to do number 4. You're going to use your scientific notation notes. We're going to do number 5, which is a reading problem. Once again, use those multiplication words. Find out if the multiplication words are attached to the fee or the meals. Number 6, we're going to be calculating interest again. We're going to practice that skill. And number 7, we're going to be reviewing what a function will look like. So go ahead, good luck,